Hello there, I'm Jimmy Vegas and this is how to create a Grand Theft Auto style game in Unity, and welcome to episode 4. So this tutorial is going to be solely focused on programming in C#. I'll guide you through every step of the way if you've never done any programming before, so don't worry too much about it. So don't forget to hit that subscribe button, click the bell icon to stay up to date with this series and everything else that I have on this channel, and with that in mind, let's start some programming. So, the idea of programming relates to pretty much everything within games, and it is kind of vital. It's the core to game development. Before we actually start creating the script, there are a couple of things that we need to explore and change and modify so we can understand how we use the script later on. So firstly, if we go to Edit and go to Project Settings and go to Input, you'll have a list of axes. And if you don't have this list, it looks like this. Just click that little arrow there. The two we are going to focus on, so we have to remember the names of them, are horizontal and vertical. These are the two input settings that we are going to use to get a simple character controller working for our character right here. So remember, horizontal and vertical. So the character itself, you remember we put these animations on. And these animations themselves were extracted from these prefabs. Now, it is worth noting that I do know some people may struggle with this because although it will work as it is, some people do prefer to use Legacy. And I think the way this entire script is going to be geared up, we are better off using Legacy. A subtle little difference about these two, especially with this character, is with the original animations that we put on, this character will walk forward. For example, if we have walk. So just to show you what I mean, if we attach walk as the main animation and press play, he will start walking forward. Because we're going to be able to control him, we don't need that on. We need the legacy ones. So this is perfect, for example, a cutscene, which we will be doing pretty soon. But like I say, to control him, we're going to use legacy. So essentially, all that really means is going into idle, holding control, pressing D to duplicate idle. Let's take run. Hold control, press D on run. Same with walk. Hold control, press D on walk. And then on the contract killer, you just need to replace those things as simple as drag and drop. So start with idle, overwrites idle. Walk, overwrites walk. Run, overwrites run. And then we'll have idle as the default animation up here. So now all we've done, like I said, is just enabled us to be able to control our player rather than him walking off or controlling himself, as it were. So let's get down to creating those scripts. So let's create a new folder in our assets window down here. So right click, create folder, scripts. And within here, we'll create another folder and we'll call this one characters. So all I'm doing here is keeping everything neat and tidy because we don't want one specific folder that has 100, 200, 300 scripts because it will be difficult to find things, at least without this search tool right here. So if we keep every character script related to any character in the game within this folder, it's easier to find. So what we need to do now is right click, create C# script, and we'll call this char, short for character, control. Hit enter. And hit enter again or double click the file and it will open up in Visual Studio. And Visual Studio is where we do all of our programming, at least I do, for this series, for Unity. Now instantly when you open it up, you'll notice about 16-17 lines of code already preset for you. This is by default and this is actually pretty interesting. So each line of code serves a different purpose. So let's start at the top. These 3 lines of code at the top are known as a namespace. And a namespace is a way of defining in the script what kind of things it needs to use. So for example, in the future, we're going to use some UI, which is basically a HUD for your game. And we need, in that case, when we do start using that, to reference in a namespace using Unity Engine and then .ui. So that'd be referencing some UI elements within the namespace. They are fine as they are because we're not going to anything too complex in this tutorial, so they're fine as they are. Next down we have the class name. Now this is important here. The name of the class, i.e. in this case char control, has to be the exact same as our script name. If we were to change the class name to say char controller, it wouldn't work because it isn't the name of the script. And same applies if we change the name of the script back in Unity to something different, it wouldn't work because the class is not the same name. So moving on, we have a couple of things here. Green lines with these two slashes, these are called annotations, and all they are is just a way of making notes in the script. For example, like it says here, use this for initialization. This one here, update is called once per frame. These are just notes. These are bits of code that are never run. The script never sees these lines of code. It's just for our reference. After this, we have void start, void update. These are known as methods. And anything within a method is where the script goes. So this is where all the lines that are executed happen, apart from variables, which I'll get onto in just a moment. So a method, for example, void start, this happens once. Void update happens every frame. Now we can call these methods whatever we want, really. There's no set limit or anything of what we can and can't call them. You just have to be a little bit careful sometimes. But it is always good practice to use proper names and start with uppercase letters. So, for example, I could say update is called once per frame, start is called as soon as the script starts. If we were to have our own method, say void GTA script, that would only be used when we call that method. But we won't be doing that just yet. It's something we'll get into later on. So I spoke about variables. A variable is a way of holding or defining data or information that the script can use and process to make it actually work. So for example, we could contain some numbers, some letters, or game objects, or pretty much anything really. Anything can be set as a variable. So in doing so, let's actually start writing this script. We only need the void update method, and we don't need void start and any annotations, so we can delete those lines of code. And when you do, you'll notice a yellow bar appear here. This means that this has been edited or modified since the last save. So now, once we hit enter and go to this line here, let's start setting the variables. So the first variable we're going to use is our character himself. So in this case, it's known as the contract killer. So we're going to call it public. And we use public because we want to see this variable appear within our inspector panel. So when we attach it to an object over here, it appears as a component. And like we see here, we have a visualization of what those variables are. But you'll see it later on in this tutorial anyway. That's why we put public. So next we have the type of variable. In this case, it's going to be a game object. The reason we have game object is simply because it is a game object. There's no other reason why, because it's an object within the game. It's simple as, really. Next comes the name of the variable. And you can call this whatever you want, absolutely whatever you want. I'm just going to call it the player because it is the player. So it's nice to keep things, straightforward. Don't go over the top making silly things. If you can keep track of that, that's totally fine. But I like to keep it nice and simple. Last thing we need to do here is a semicolon. So almost every line within a C# script will end with either a semicolon or curly brackets. Which brings me on to something kind of cool. If you go to a closed curly bracket, you'll highlight where it begins. So in this case, this one closes this one. And this one closes the public class. So next one, let's have a bool. A bool is either true or false. So it's one of two conditions. It can't be both. It's either one or the other, true or false. So once again, public bool, that's B-O-O-L, and you'll notice here I've put bool with a lowercase b, although game object had an uppercase G and an uppercase O. Coding, you need to be case sensitive. Everything is case sensitive. You need to be very, very mindful of that because the simplest little capitalization error could throw the whole script out. So that's the type. And then we'll call it is running because he's either going to be running or he isn't. So it's true or false. Next, we're going to have a float. So public float. A float is a decimal number, but it can also be a whole number. So on the flip side of that, a whole number is known as an int or an integer. However, that cannot be a decimal number. So a float can be both, but an int can only be a whole number. So this is likely to be, let's say, a decimal number at some point. So we're likely to call it a float. And this is going to be horizontal move, semicolon. And because we're doing this on 2 axes, horizontal and vertical, you should have guessed it. The next one is going to be public, float, and vertical move, and semicolon. So we are having 4 variables, just 4 variables, at least to get our simple character moving along nicely. So in the void update, what we now need to do is create the lines of code which allow us to play the animation to run and to actually make him move. But in doing so, we need to make sure we're actually pressing the correct buttons. In this case, we need to use an if statement combined with a logic gate. Now, a logic gate is something like and, or, things like that. In this case, we need to make sure we're either pressing horizontal or vertical. So either WASD. WS being the movement up and down, and A and D being the rotation of our character moving him around one way or the other. So let's start with if, and in brackets, we need to check the input. So input, which is basically the keyboard, and we're checking the button. So get button. And now what we need to do is check which button we're pressing. In this case, let's start with horizontal. So are we pressing W or S? So open bracket and quotes. And remember what I said earlier when we checked in that edit menu, horizontal. Make sure we do spell it right, because that will make the whole script not work. It does have to be spelt right here. And then quote and close bracket. Now there is one thing to note here. Sometimes Visual Basic will kind of autofill things because it thinks that's what you're doing. Usually, if this was just one if statement, these 2 close brackets would be perfectly fine. However, because we're doing an or statement, we're having horizontal or vertical, we now need to put a space after the first close bracket and put the or symbol. Now this or symbol is just basically holding shift and pressing the button next to the Z or Z key on your keyboard. For reference, the and symbol are 2 ampersands. So here we have or and. So it's either one of these 2. So because we don't need the 2 buttons at the same time, we don't need and. We're doing an or statement. So we use these 2 lines right here. So obviously we now need to put input.get button, and in brackets and quotes, vertical. Quote, close bracket, and then open curly bracket and press enter. So to quickly recap this line, what we've done is we have said if we're going vertical or horizontal, then we need to perform the following lines of code. And that's what this if statement is all about. So everything we put between these 2 curly brackets here will be executed when we either press up or down, left or right. So this close bracket here, as you can see, highlights here. So you can see this whole thing is now self-contained. It's now complete. If you were to make a mistake, it would underline in red and you'd be able to see that there'll be something wrong. So let's say we've pressed our button. We're going forward. We're doing whatever. Let's play that running animation. So the player dot get component. Now the reason we do this is because the player is that game object, so it's going to be the player, and we're getting the component. So we're receiving information from a component or sending information to a component. In this case, it's called animation. That's the component we need to reference here. And we can do that by doing it inside spiky brackets. So type animation. And remember, it is case sensitive. The capital A is important. And when we close the spiky bracket, we'll be able to see that it's highlighted in blue. That means it's a valid component. Then open close bracket and then dot play, because we want to play the animation contained within the animation component, and we'll play the animation in spiky bracket, sorry, not spiky brackets, in curly brackets and quotes, and we'll call it run because that's the animation we're going to do. So quote, close bracket, semicolon, and that's that line of code. So at this point, if we were to press up or down or left or right, we'd play that animation and it would stick with that animation. So next thing we need to do is change the actual frame that we're moving. So we need to actually make him move. And we can do that by going horizontal move. So we're now making this horizontal move equal to a number that we can go forward with. So horizontal move equals, now let's see, what can we do to make this move? What is the math to make this work? And basically all we need to do is get the axis value of horizontal. So for example, 1. So we can have input dot get axis, and in brackets and quotes it's the same again, having horizontal. So we have to make sure that the horizontal move always relates to the horizontal input. So we can have horizontal, so it is the same spelling right here, and then quote, close bracket, and then we now have to multiply that by something called time dot delta time. And all this does is allows us to move our character relative to the world around us and the time frame that the game is in. That's the easiest way to explain it rather than anything, but top and bottom of it all is that needs to be in there so it's relative to how the game world is. So it basically makes him move, look like he's actually running properly rather than sliding along the floor whilst running. And then multiply that by the speed in which he can move. So in this case, the horizontal is just a way of turning ourselves around. So we'd spin ourselves around pretty quickly, I would think. So let's have this as a high number, around 150, and semicolon. Next, we're going to do the exact same, but for vertical move. So that will be vertical move, and although it's called vertical, it basically means forwards and backwards because that's just how this axis works. So just to give you a bit more insight to that, vertical is going along on the Z axis because this is his forwards and backwards, and the rotation is obviously on the Y because he's turning around. So we just need to bear that in mind for the next few lines of code. So vertical move is going to be equal to input.get axis, and in brackets vertical, and then same again multiplied by time dot delta time to make his movement relative to the game world, and then multiplied by his move speed. Now this is not going to be too high, but it's not going to be too low. So I'm going to put this as 8 and see if that is acceptable when we play test the game in a couple of minutes time. Remember the semicolon at the end to finish the line. So at this point, our character is moving. He's running. So let's set that bool as true. So is running equals true, semicolon. And we can see we've done it right because it highlights blue. So this isn't really necessary at the moment, but when we get further into coding and development, this is where this variable will come in quite handy because it gives us a little bit more control later on of our character's actions. So we've got the animation going, we've got the speed at what we want to rotate and move forward. So now we're going to use rotate and translate to make this actually happen. And to do that, we need to access the transform component. What this will do now when we type transform is it means whatever object this script is attached to will do whatever we tell it to in this transform line. So transform dot rotate and open bracket, and within here we need to rotate on the horizontal move number. So we need to basically rotate based on whatever number has been generated from this line of code. And because we do it on the y-axis, remember we have x, y, and z, we don't need any change on the x, so we have 0, comma. We do need it to change on the y, so we need to put here horizontal move, comma, and now we don't need any change on the Z, so we can put 0, close bracket, semicolon. And now we do the same again, transform, and instead of rotate, we have translate. And what translate will do is, rather than translate foreign languages, is it will actually move the player in whatever direction it's facing at the speed we now dictate in the Z axis. So, translate. Remember, capitalization is important. And in brackets, we don't need any movement on the X. We don't need any movement on the Y, so both of those are 0. But we do need movement on the Z because that's our forwards and backwards. So that will be vertical move. Close bracket, semicolon. So that is that if statement pretty much done. That's all it is to creating a simple character controller, I should say. So what we're doing is checking if we're pressing the buttons, and if we are, we're animating, calculating how fast we should be going, saying we are going, and then we are going ourselves. So what happens when we lift the keys up, when we stop running? Well, what we have to do is, rather than do another if statement, after the close curly bracket, to close that if statement, we can go down a line and type else, and then open curly bracket and press enter. So what this means that basically, if this doesn't occur, then this will. And what we really need to do is have the player just stand idle. So the player dot get component in spiky brackets animation, just like above, open close bracket dot play, and in brackets and quotes idle, because that's the name of our idle animation. You have to make sure these animation names here do match whatever you have. So if you use the same character as I have, then these are likely to be exactly the same. So quote, close bracket, semicolon, and finally we'll have is running equals false, semicolon, and save. And you can save by holding Control, pressing S, and when you do, you'll notice those yellow lines now turn green. This means that this entire script has now saved. So if we head back to Unity, in the bottom right corner, we'll see a little time thing happening. All this is doing is Unity compiling the script just to make sure that it is okay. If you get an error down here, click on the console and you'll see here an error. You'll see an error code and likely what's wrong with it. For example, if we had here, remove that semicolon and save, in Unity, it will come up with an error like this. Now, the good thing about the console is it does give you more information than what you think. Error CS1519 doesn't necessarily mean anything, but yet again, void in class structure, that doesn't necessarily mean anything, especially to somebody who is, well, new to scripting. If you double click it, it will take you to roughly where it thinks there is an error. And you can usually go forward a little bit or backtrack a little bit to see where the problem is. And we can see here there is a little red line saying something doesn't look right. And if we hover over it, it's saying semicolon is expected. So let's put that semicolon back in, save the script, head back to Unity, and that error should now disappear. So great, we've written the script. How do we use this? How do we get it working? So what we need to do is drag and drop this script onto the character up here in the hierarchy. And all this will do, as I said earlier, is create that script as a component. And remember when I said we have public on the variables, that's because we can then see them here. So these are each of the variables that we had. This is the game object, this is the bool that we had, true or false, and these are the two floats we had. So now what we can do is we can ultimately define the player by dragging and dropping a game object onto here. So drag and drop over here, and you'll see that it fits it in nicely. So now when we press play, we should be able to control our character. But before we do, to make sure we actually can see where our character is going, let's do something real simple. Let's drag and drop our main camera onto our player. And you can see that's what the camera is now rendering. And our camera should quite easily follow our player wherever he walks. So let's press play and check this out. There we go. So now we're moving quite nicely. So it's a simple character controller. There's quite a bit to it. Realistically, he shouldn't really be running on the spot, but for now, this is as great as it's going to be. There's a lot more to it, and what I think we'll do next tutorial is we will actually work on this a little bit more. We'll have a camera script, or we'll set one up to allow us a bit more better camera motion, and I think ultimately this actual character itself, this isn't going to be the final scene we're building here. We'll eventually have a massive world and everything, and we'll refine the scripts more as we go along. I feel that I don't want to rush into C# because there is a lot to learn, but I feel with this series we need to get to grips with scripting sooner the better, really. So next tutorial we're going to create some camera control with some C# scripting, and we're also going to build up this scene ready for the future. Now there's not going to be massive amounts of detail to this scene as we start, but as we gradually build towards the scene completion, it's going to look pretty awesome, guys. It's going to look pretty awesome. So guys, until that next episode, please, you feel free to modify this script in any way you want. You kind of build it to your expectations, and if you have problems, head over to the website, download an asset, and you can get it there for absolutely nothing. It's free, so why not? So finally, let's save that scene. Perfect. And we'll see you in the next episode. Guys, thank you very much for watching.